So today, as I've said, our topic today is statistics. And I've said statistics is a branch of mathematics that deals with collection, organization, representation, and interpretation of data. It deals with collection. So you start by collecting data. Let me just share this one so that you can see. So this is my screen here. So I'm hoping that you can see my screen properly. Okay. So you collect, you organize, you represent. Okay. You represent and you interpret data. Now, when you interpret data now becomes, by the time you get to this last stage here, your data is information. So data is something that it does not make sense. For example, you can see on this example that we have below here, given below are marks obtained by 20 students in math out of 25. Yeah, you can see the marks here. This is data, just collecting some we call it raw information. It's raw data. Then when we process it, so we collect it, we organize it, we represent it, and then we interpret. So I'm going to show you how we represent and how we interpret and how we organize. So we start by collecting first. So the next stage we'll go now is to organize this data, okay? Then we represent it and then we interpret it. I'm going to show you how we interpret that data. Then by the time we interpret it, it now becomes information. It can be used meaningfully. So we can, for example, the government does something called census that was done last year. So it's very, very important when it comes to national development, knowing in a certain area or in a certain country, you can know how many people we have, what are the number of hospitals, number of schools, and then we can be able to see how many schools in a certain area, how many schools are serving a certain population, how many hospitals are serving a certain population, roads, all that information. Okay, so that one now, after you interpret, when it is now planned properly, you collect it, you organize, you represent, you interpret. It can now be used, okay, to do actions, to provide infrastructure by the government. It can be used for the purposes of planning in the national budget and so many other things. So it is very, very important that you start with something that does not make a lot of sense, but at the end of the day, it's supposed to make a lot of sense. Please make sure when you get here, you mute your mic. I will allow you to talk. At a particular time when we'll be asking questions. So that is what we are going to do. So when data is not organized, it is saying to be raw data. So when you're just collecting it, before you start organizing, we say it is raw data. Okay. So it cannot be used to make to make important decisions. But when you organize, you present and interpret, you can use that to make important decisions, okay? Either for an individual, for an organization, or even, as I said, for the government. So we will start with this first example here. So given below are marks obtained by 20 students in maths out of 25. Let me just put here in maths. Now, so we have this marks here, so that it was a cut or a test or anything, so it is out of 25. So the most important, the first part I want us to cover is we look at something called a frequency distribution table. A frequency distribution table. So what is a frequency distribution table? Now, it is a table that looks like this. Okay, this part is not here. This part here, this part is not here. So just leave this part alone. Okay. So it has marks, it has tally, it has frequency. So I'm going to explain marks. You can see marks is what is given here. So when you draw a frequency distribution table, you start by looking at the smallest mark. You see the smallest mark is 12, okay? And the highest mark is 25. And then you arrange them chronologically. You arrange these marks chronologically. It means you arrange them from the smallest to the highest, or you can just do it the other way around. But for the purpose of the frequency distribution table, just draw from the lowest to the highest. Okay. So you see the lowest mark is 12. The next mark is 15. Okay, you just write 15 once. Okay. Then the next mark is 17. Then from there we have 19. From there we have the next mark as 21. The next mark as 23. And the highest mark is 25. Remember, this test was out of 25. Now, in the column of tally, tally is where you do your calculation. So, how many times does 12 occur? So let me just do away with this and show you how it is done. How many times does 12 occur? So you come here on this table, you see, on this data that you have collected here, this raw data here, you find that 12 occurs once. That you represent it using your pen or your pencil, whatever, you're going to be writing it with a stroke. Like you can see, I've put a stroke here. Now, 15 here occurs how many times? 15 occurs 2 times. So you're going to put 2 strokes, like you can see I've already put here. Okay, 17. How many does 17 occur? Once, twice, thrice. So you start here. Where you see 17, you just put a stroke. So you start by the first stroke here. You come here to the second 17, you put another stroke. And then here you put another stroke. Okay, you continue to the next mark. You see it is 19. 19 occurs how many times? 1, 2, 3, 4, 5. So let me show you how you write 5. So this is how you write 5. You put the first stroke, 1. Let me just come here and show you properly. So you put the first stroke 1. You go to the next one. You find this is the first stroke. So I come here. This is the second stroke. The second 19. I put another stroke. So that 19. I put another stroke. The fourth one. The fifth one. You don't put a stroke. You just cross. Okay. Like you're just canceling here. So that is how you do. So the fifth one, that's how the fifth one is written. Then you go to 21. 21, there is 1, 21, 1, 2, 3. So you put 3 strokes here. 23 occurs 1, 2, 3, 4 times. And then 25 occurs the highest mark. It only occurred 2 times. Okay? So you put 2 strokes here. Then on the frequency now, frequency means now this is the number of times it occurs. So this tally is where you count. Frequency is where you present that one on the table. So 1, you put 1 here. You just count the strokes. 1, 2, 2. These are 3 strokes. 3. These are 5. You say that is how you count 5. These are 3 strokes. You put 3 here. These are 4 strokes. You put 4 here. These are 2 strokes. You put 2 here. Okay. Now, if you are writing a number like, let me come here and I just do something and then I delete. For example, let's say you are writing. You wanted to represent a number like 6, so you're going to put 1, 2, 3, 4, 5. Your number is how you write 5. 5, you just cross them. Like, okay. And then 6, you put 6 here. So this is how you write 6. So 1, 2, 3, 4, you cross them. That's the fifth one. 6. If you want to write 7, put another 7, another stroke there. 8, 3 strokes there. 9, 3 strokes there. 10. If you want to write 10, you just come here. Okay. If you want to write 10, just come here and izishikane because hii yangu ni kama inashikana. Let me show you. So this is how now you would write 10. So this is how you write 10. Okay. If you want to write 11, you just come, you want another stroke here. 12, you want another one. 13, you want another one. So you calculate, when you see they are crossed, these are 5. So if you have crossed them 2 times, it means these ones are 10. So you know this is 5, 5, 10, then 1, 2, 3. So that is how you do your tally. Okay. So this is how you do your tally. So I think that one is very, very important. So let's come back here. Then we continue with what we are doing. Now, so you have now come here and you've put your frequency. Now, you need to have the total frequency. You can see this we are told these are marks given by 20 students. Marks given by 20 students. You need to have a total of the frequencies. Now, in the total of the frequencies, we use a Greek symbol called sigma. As you can see here, this is a Greek symbol here. This symbol here, as you can see, I've put it here, is a Greek symbol called sigma. This is how sigma is written, okay? Yeah, it's written like that one. So I can show you sigma here in my, let me show you sigma. So this is where I write sigma. I'm hoping that you can see this. So my sigma is a Greek symbol, so it's supposed to be here. So this symbol, you can see my sigma is this one. This is what sigma looks like. So it is a Greek symbol called sigma, and it means sum of. Okay, sum of. So when we talk about sigma f, it means sum of frequencies. It means 1 plus 2, 3 plus 3, 6 plus 5, 11 plus 3, 14 plus 4, 18 plus 2, 20. So sigma f, sigma is S-I-G-M-A. It means summation of frequency. So when we talk about sigma f, we say is equals to 20. It means total frequencies is equals to 20. And that one is in order. Remember here we are told marks is for 20 students. It is very, very important that you know this is how we do a frequency distribution table. So this part, the selected part, is the only part that represents the frequency distribution table. And in your exam, it carries a number of marks. Okay, it carries up to 5 or 6 marks. So it's a quite pretty number, a good number of marks. I think that is very, very important to know that this is a very serious topic, just like all the others. But you see, just coming up with such a simple table, you're able to get such a good number of marks. So it is very good that you're able to understand this question. Okay, so this is what you call a frequency distribution table. As you can see here, I've said of ungrouped data. As you can see, this data here is on itself. We call it discrete or ungrouped. Please, your mic should be off. I said you mute your mics. I don't want a case of us having a lot of noise here. So just mute your mic so that your background noise does not affect us. So this is frequency distribution of ungrouped data. Ungrouped means this data is on itself. Every mark is on itself. Okay? We have not put the marks in a group. Kuna mtu anatukosea. Someone is not doing us justice, and I want to know who that one is. Anakosa sana. Remember, I've said that if you are here for the lesson, you can go there and you can take your attendance, although I'm going to see you. I've already removed the screen share because I need to know who is making noise. So let me come here. let me come back here and just okay. So we continue back with our screen share here. So if I stop recording, someone to just remind me that I'm not recording this. So let me share my screen again. I come here, and this is where we are. So we want now to look at how to draw a frequency distribution table for grouped data. And we have said that this data are the classes in a primary school and the following. No, we said this one is not important. This one is not going to be important here. So this one is given the following row scores in an algebra examination. So we are going to come up with a frequency distribution table using these scores. These are scores that were gotten by students in an algebra examination. Okay, and I've said in the instruction, I want us to come up with the grouped data with a class interval, with a class width, or a class size of 5. And I want to show you how to come up with a certain class size. So FDT means a frequency distribution table. So we compile a frequency distribution table of grouped data with a class size of 5, a class width of 5, a class interval of 5. So any name that I use, class size, class width, or class interval, they mean the same thing. So I'm just going to be using one name, and then you understand what I mean. So we want to use a class size of 5. Now, how do you come up with a group? So I've said you come up with a range of a data. So the range is the difference between the highest and the lowest score. The highest and the lowest. So it means the difference here is, it means you subtract the highest score, okay? You subtract this lowest score from the highest score. So you come here, it's just a matter of observation, which is the highest mark. So here I can see it's 28 in the first row. The second row I can see is 38. This one I can see is 33 is the lowest in this part. So this one is 39. So I can say with confidence that the lowest score is 28. 28 is the lowest score. So let me say the highest score. This is 59. This is 66. This is, oh, sorry, 70, the highest score here. 72, I guess. 77, 80. So 80 is the highest score. So we find the range, and we can say here, range is equals to, okay, 80 is the highest score. So 80, you subtract what? You subtract 28, and the answer of 80 is equals to 28. So you can say range 80 minus 28. And this one, I think, is it 52? You just get the answer to that one there. So I can see my range there is 52. 52 is a good range. Okay. Then from there, so you have seen what the range is. And we know that we want to use a class width of 5. So we come here and say number of classes is going to be found let me put this on here. It's going to be found by range and here by the class size. Remember, I've said class size is the same as class width, it is the same as class interval. So I'm just going to be using one name. Okay, so you can say in short here, it is 52 over class size is what? 5. So if you come here and you divide 52 by 5, I'm not going to be sharing my calculator in this particular case. So make sure that you confirm using your calculator at home. So 52 divided by 5 is 10.4. Is 10.4. Now, from experience, 10.4 tells me these are 12 classes. Now, the optimum number of classes that you should have is 6 to 12. So when you are having group data, your classes, unless the examiner tells you otherwise, your classes should not be less than 6 and should not be more than 12. So the number of classes that we have had here are 12. So you can see ours is within the required range. So if you have 5 classes, doing the wrong thing. If you have 10 classes, doing the wrong thing. I said unless the examiner has warranted you do it. Okay? But for the purposes of our classwork and for the purpose of the examination, if it is left to you to decide the number of classes, they should be between 6 and 12. What does that mean? It means you group your data into an interval of 5 or into a size of 5. What does that mean? So it means if my lowest data is 20, okay, or if my lowest mark is 20, I'm going to have 20, 21 as the second one, 22 the third one, 23 the third one, and the fourth one, and then 24 the fifth one. So this class I'm going to write it as 20. Now we say just 20 to 25. 20 to 24. So 20 to 24 means it's the class size of 5. So it is 1, 2, 3, 4, 5. So when I write 20 to 24, it means this one is the class size of 5. So most of us come and say 24 minus 20. And they get the answer is 4. So you tell me the class size is 4. No. So if you want to know the class size, we say 24 minus 20. Sorry. What have I done here? 24 minus 20 here. Then we say plus 1. So why do we say this? So I'm going to enter this one in this page here. Why do we say this? Now, the number 20 here is called, listen very carefully. The 20 to 24, the number 20 and 24, they are called class boundaries. So 20 becomes the lower class boundary. That's 20, that's the number 20. So the number 24 now is a class boundary, but on the upper side, so it becomes the upper class boundary. Upper class boundary. So you have the lower class boundary. So here. So you have the lower class boundary, and then we have the upper class boundary. So 20, that's what the number 20 and 24 represent. They are called class boundaries. Okay, class boundaries. So for you to get the class size, you can say the upper class boundary minus the lower class boundary, and then you add 1. Because it literally means 20 to 24, it means 20 is included. So we have 20, 21, 22, 23, 24. Count 1, 2, 3, 4. Write it. You write it 24 to 20. Okay, you write it 24 to 20. So that's how it is written, 24 to 20. Okay. So you write it as 24. Sorry, that's 20 to 24, not 24 to 20. 24. Okay, but if you want to find the class size, you say 24 minus 20, then you add 1. So you now get your answer as 5, and that is the correct answer. So in our data here, we will come and we have said we are going to start with the lowest one, a class size of 5, and we saw the lowest one was 28, the highest one was 8. Okay, so if the lowest mark is 28 and the highest is 80, I want to come up with a class size of 5. The best way to come up with a class size is like this. Let me say let the first class size be from 25. Okay, so 25, 26, 27, 28, 29. So my first class is going to be from 25 to 29. So 1, 2, 3, 4, 5. So I continue doing like that. The second class size is going to be what? Actually, let me insert a table now so that we can do it once. I don't have to keep on doing it again. So I insert a table. Let me insert 14 of them. So this one I'm going to call it marks because these are marks gotten in a algebra exam. So this one I'm going to call it tally. And this one I'm going to call it frequency. And frequency is abbreviated as F. Okay? We abbreviate it as F. As F. So marks, these are going to be the groups now, or the classes that we have here. So the first class we have said, let it start from 25 all the way to 29. So the next class obviously starts at 30. 30 is going to be 32, 34. Okay? You can just write them 30, 31, 32, 33, 34. Then the other one starts at 35, goes all the way to 39. The next one starts at 42, 44. The next one starts at 45, ends at 49. So as you can see, it's a pattern. As long as all the classes are equal, it's just a pattern. Okay. Then we have 52, 54. Here we have 55 to 59. And then we have 62, 60 to 64. Sorry. Then we have 65 to 69. Then we have 70. You have 70 to 74. You continue all the way down. Then finally you have 80 to 84. Now we said at the end of F here, you require to have a summation of F. In the F column, you require to have a summation of F. Let me just make this one small. So in the column of F, you require to have a sigma F. So let me insert my sigma here. The sigma is here. Sigma, we have said in the Greek symbol that means summation of F. So sigma F is equals to, we are going to get them there. So let us now come to the tally. How do we do the tally? So I'm just going to show you how you do the tally simply for the first like 3, and then I use the table that I've already calculated here. So you just look properly at the first 2 examples. So I usually come here and make this one smaller so that we can. Just a moment. I want to do something here. Just good. So as you can see here, I wanted to make it in such a way that we can be able to view this. So I look at this. I look at. I have said that my first class is going to start from 25 to 29. From 25 to 29. Let me just go to one page. It's going to give me the way I want. It's not giving me still the way I want, so no problem. Let me come back to my one page. So here. So how many times do you get? We start with the first class we have said is 25 to 29. So this is how you do it. So I can go either per column or per row. So I'm going to start with the first row. Anything between 25 and 29, I can see one. So if I see one, I'll here and I'll put a stroke here in the first row. Okay. Or I can do it this way. I can go and put every mark where it's supposed to be. So 47. So the first one is 47. The second one is 56. So 47 is here. 56 is here. Okay. Okay, then I go to 42 and 28. 42 is here. 28 is here. Uh-huh. 56 and 41. 56 is here. 41 is here. Okay. I need you to view everything. Okay, so 56, 55, 59. 56 here. 55 here. 56, 55, and 59. 56, 55, and 59 in the same place. They're in the same place. So the fifth one, I'm just going to come here and okay. This is how this one is going to be. So this is how you get the fifth one. So 1, 2, 3, 4, you cross the fifth one. Okay, so you do it all the way. So you come to 78. 78, you put one here. Okay, you say 50 and 55. So 50 is here. 55 is here. Okay, so I'm just going to do up to the second row. 57, 38. 7 is here. 38 is here. 38 occurs between here, that is. Then 62, 52, you come to 62. 52 is here. 66 and 65. 66 is here. And 66 are what? You have to be very careful. And 66 and 65, they're in the same, I think, yes. 66 and 65 are going to be the same place. So I come, I put another one here. So at the end of the day, you continue putting them like that. And this is what I'm going to have. Okay, so in my tally column, this is what I'm going to have. Okay, so I'm going to have this. So 25 to 29 was 1, 30 to 34 was 2, 35 to 39 was 3, 40 to 44 was 3, 45 to 49 was 3, 50 to 54 was 5. You can see the way 5 is written. 55 to 59 were 8. Okay, 60 to 64 was 5. 65 to 69 was 4. 70 to 74 was 3. 75 to 79 was 2. 80 to 84 was 1. And then you come here and then you calculate this sigma f. So it is 1 plus 2, which is 3, plus 3, 6, plus 3, 9, plus 3, 12, plus 5, 17, plus 8, 25, plus 5, 30, plus 4, 34, plus 3, 37, plus 2, 39, plus 1, 40. So it is sigma f is equals to 40. So this part here is the part that represents the frequency distribution table. That part. And that part alone I've seen in the exam is up to from 5 to 6 marks from the examples that I've seen in other in your past papers. So that is what we have. So this is what is called a frequency distribution table. You now see the difference between this and whatever we have done here for this data here. You can see it is quite different. This is ungrouped data. It means every number is representing itself. But you can see here, in this particular case, you have to put your numbers into groups, okay? And we have said the class size was 5. The class size, the class width, or the class interval, they mean the same thing was 5. And we have said, how do you come up with the grouped data? For this data, you find the range, which is the difference between the highest and the lowest score. So we have said that the highest is 80, the lowest 28, difference is 52. So how many classes should you have? You should have 6 to 12 classes, unless if the examiner has done otherwise. So how do you find the class size? The number of classes, you find it by range divided by the class size. I'm the one who had decided we start with the class 5 of, with the class interval of 5. So 50 by 2 is 10.4, which gives us, someone can say it's approximately 11, but it's not 11. Actually, it takes you to the next number. So if you get a number like 9.8, you know that these classes are not 10, but 11. That's how you know. So there are 12 classes, which means they are within our range. Okay, then you now start by writing it like this. So this here, ladies and gentlemen, is very, very important. So max, tally, frequency, this one forms your frequency distribution table. So you fill the whole of it. You fill the whole of it like that, just like they have shown down here. And then you find the frequency. For example, if this was the final table, you would have said this one was 1, this one was 1, this one was 2, this one was 1, 2, this one is already 7 up to here. So that's how you fill this frequency distribution table. So this is how you fill it. So to Kohapa. So you fill it, and I've said this is only part that represents the frequency distribution table. The rest of the part I'm going to explain its purpose. I think I should. What is wrong with Kialo? I think that one is in order now, so that people don't keep on making noise while I'm speaking here. Yes, I think this is in order. That is in order. That is in order. In order. In order. In order. In order. A moment. So yes, that is what I wanted us to do first, and then we can now continue from there. We can continue from there. I think is a good thing. The next, since we have looked at that, the next thing in our course outline, if you look at the course outline, we are going to look at the mean, the mode, and the median. The mean, the mode, and the median. These ones, we call them measures of central tendency. Measures of central tendency. You have the mean, the mode, and the median. The mean, the mode, and the median. There's someone I cannot see here. Just a moment. Okay, so we now move on. So I continue with my screen share to the other parts of this lesson. Measures of central tendency. The mean, the mode, the median. Okay, measures of central tendency. Here, you have the mean, the mode, and the median. What do these mean? What is the mean? You know, mean is an average. For example, if it is math, we talk about in school, something like that. Mode is the most occurring. Okay, mode is the most occurring frequency. We are going to talk about the most occurring frequency. Then we have median, the central most. Okay, the one which is in the central most. So we have mean, which is the mean, which is the average. Okay, for example, we can talk about a mean score. So I'm going to show you how to calculate that. We have the mode, and we have the median. Mode is the most occurring frequency. So, for example, in this table here, if you ask what is the mode, out of these marks ambazo zilipatwa hapa, which was the mode mark, which means which was the mark ambayo ilipatikana mara mingi sana. So it is the highest frequency. So we come here to frequency. We see the highest frequency. We have 1, 2, 3, 5, 3, 4, 2. So which one is the highest among these 5? So we go to the mark. So 19 mark ilikuwa imepatwa mara 5. So it was the most occurring mark. So the mode mark is 19. So if you ask for that, that is how you answer. For ungrouped data, that's how you answer. What about the median mark? Median mark is a central. Median mark is the centralmost mark. And how do you do that? How do you do that? You arrange for the median. You arrange the numbers. You arrange these. Okay. You can arrange them from highest to lowest. Or lowest to highest. And then you find the centralmost score, ile ya katikati sana, the central. What I did here is this, for these marks, this one, all these ones, I arrange them from the lowest to the highest. So there was 12, 15 was 2 times, 17 occurring 3 times, so you say 12. Kama 15 mbili unaandika 15, 15, 17 were 3, 17, 17, 17, 19 were 5, 1, 2, 3, 4, 5, 21 they were 3, so you put them like that, and then you move on. So what it requires you to do is, let me just come here. You find the centralmost score. So you just start by cancelling. So you cancel, you start cancelling the ones at the end, okay? You cancel that one. You cancel this one here. You come to 25 here and cancel. So you cancel. I don't know why this one are not cancelled here. Cancel 12. You cancel 25. So unachukua moja moja. Now, mimi sitachukua moja, nitachukua kadhaa. I know these numbers are 20. So I can take like 7 or 8. So I can say 1, 2, 3, 4, 5, 6, 7, 8. So nichukue mpaka hapa. So from 12 to here. Kwanza 8, I cancel. Nichukue zingine 8 hapa. Mbona najua zitanifikisha hapa. So that's 16, so I'm going to be left with 4. So I cancel 1 here and I cancel here. So I'm left with the 2 central most. So I'm left with what? 19 and 19. So if I'm left with 19 and 19, how do I find the median? I say 19 plus 19 and divide by 2. The answer is 19. So I'll say the median mark is 19. So 19 was the mode mark. It is also the median mark. It is the centralmost mark. Let's say we have numbers like, let's say we have 2, 4, 1, 8, 5, and 7. 1, 2, 3, 4, 5, 6. Now I want to have, let's say we have another 4. Okay. So if you want to find the median mark here, you arrange them into lowest to highest or highest to lowest. So you can do it anyway. So you can even start with 8. I go to 7. I go to 5. I go to 4. I go to another 4. Then I do what? Which is remaining. Then I go to 2. Then I go to 1. 1, 2, 3, 4, 5, 6, 7. Yes. So you start removing 6 and 1. Okay, I cancel 8 and 1. Okay. So I cancel 8 and 1. So I go next to 7 and 2. Then I go to 5 and 4. So I'm left with this 4 here. So if you're left with 4 alone, it means here the median mark is 4. Median is equals to 4. So you just continue cancelling them, and then you're left with the centralmost one. When you cancel the others, in this case, it's going to be 4. So you cancel those and those, and then you're left here with 4. So that is how you do the median. Now, how do you do the mean? How do you do the mean? Mean is very, very important. So how do we do mean? We introduce another column here. You can see the marks column, we called it X. Because X is whatever you are calculating. Okay? So whatever you are calculating data, it is called X. So marks does not have anything here. Frequency is F, is abbreviated as F. So you have another column called Fx. Fx means F multiplied by X. So for example here, the first one I'm going to have F1 by 12, which is 12. 2 multiplied by 15, which is 30. 3 multiplied by 17, which is 51. 5 multiplied by 19, you get your answer here. 3 multiplied by 21, you get your answer here. 4 multiplied by 23, you get your answer here. 2 multiplied by 25, you get 50. And then in the In the fx column, you also require to have a summation. So you require to have a sigma fx. So you have 12 plus 30 plus 51 plus 95 plus 63 plus 92 plus 50, and you get here the answer is 393, or whatever answer you're going to get here. Okay, so you add those ones. So to find the mean, you require to introduce a column called the f. So fx column means it is f frequency column multiplied by the x column. Marks, it can be mark, it can be shoe size, it can be number of vehicles, it can be number of children, x can be anything, whatever you are calculating. Here we are calculating given below are marks. That's why marks becomes x. So you find fx and then you find summation of fx or sigma fx. So how do you calculate mean? Mean in mathematics we call it as this symbol here. You can see here. This is called the bar x. Bar x. So let me make it bigger so that you can see. So mean in statistics we write it as bar x. How do you find mean? Mean is found by sigma fx. You divide by sigma f. Summation of fx. You divide by summation of f. Sigma fx, you can see here from my calculations here, it was 393. Sigma f was 20, so it is 393 over 20. The answer was 19.65 marks. 19.65 marks. Now, you can see 19 was the highest mark. 19 was the centralmost mark. And you can see around 19 is where we have the mean mark. So that means 19 in this case was a very special kind of a mark in this test. So that's how you do mean. So mean is abbreviated as bar x. That's how you write mean mathematically. You don't have to tell me mean. So you just write bar x is equals to sigma fx over sigma f. Sigma fx is summation of fx here, and fx is means the frequency column multiplied by the x column. In the x column we had marks. So obviously this one is going to be the mean mark. 19.65 marks was the mean score, or it was the mean mark of that in that particular test. So this is how you would find the answer, or this is how you calculate the mean, mode, and median, which you have said they are called measures of central tendency. They are measures of central tendency. Okay? Why? We say these are values around which data tends to cluster. As you can see, the data is clustering around 19. The minimum 19 point something. Okay? Mode 19. Median 19. So your data is going round and round. Inazunguka a certain mark, which was 19 in this particular case. In this particular case. Good. Having said that, let us now go to how we find the grouped data, how we can find the mean of grouped data. So obviously to find the mean, you require the fx column. Okay, so you require to have this column filled out, all of it. Just a moment. Just a moment. So I'll take you to this example that it's already calculated. Okay, so this column is not here. So as you can see, the column that I want to, if you want to find the mean of grouped data, you just multiply the f and the x column. Now for grouped data, max is not the x. We have another column that we call the x column, and there is a column that I'm just going to come and introduce here. So tally column now is not. Let me just add another column here and show you how we do. We want to add some more columns. So I want to do some columns here. So to have the X column, X is called the midpoint. For group data, the X column is called the midpoint. What does midpoint mean? Follow this one very closely, please. Midpoint. How do you find the midpoint, for example, of 25 to 29? This is how you do it. So you come here, you say 25, you put into bracket, say 25 plus 29, you get the answer, and then the answer you divide it by 2. In short, I say 25 plus 29. Remember, I'm not sharing the calculator here. My answer is 54. 54 I divide by 2. My answer is, we divide 54 divided by 2, we get the answer is 27. So the midpoint for this class here is 27. I want you to see a pattern. Let me do this one here. 30 plus 34, the answer is 64. 64 divided by 2, the answer is 32. 35 plus 39, 35 plus 39, the answer is 74. 74 I divide by 2, I'm going to get this one as 37. Let me see. I can see something here. Something is happening here, a pattern. What's the difference between 27 and 32? 5. What's the difference between 27 and 32? 5. The difference between 32 and 37? 5. Why am I getting a difference of 5? Now, class size, class interval, or class width is 5. So all the classes are even, or they are equal. Zinaachana, the difference between the upper class boundary and the lower class boundary is 5. Okay, and it's the same for all the classes. So if this is 27, I find the midpoint of the other one, and the classes are even, that is the class width is the same. I say 27 plus 5, I get 32, plus 5, 37, plus 5, 42, plus 5, 47, 47 plus 5, this is what, 62, I go to 67, I'm adding 72, I go to 77, and finally here I go to 82. This is how you find the midpoint. It is very easy for you to find the midpoint. Very easy. Because if the class width is the same, you don't have to calculate each and every midpoint. You just have to come. You just have to come and just find, and you just find the first one around the class width, or you find the last one and then you continue subtracting, which I don't think you choose to do that. So you just find the first one is 27, then you say plus 5, plus 5, plus 5. Why? The class width is 5. Every class happens in a tano. All of them. So the class width is even. It is the same in all the classes. So this is how you get the midpoint, which is your x. So when you're now coming to your fx, you are now going to multiply midpoint, not the classes, midpoint and the frequency column. This is how you do it. So this is what I'm going to do here. I've already calculated it here. So let's see. Frequency here was 1. Midpoint is 27. So fx, it is f multiplied by x. 1 times 27 is 27. 1 times 32 is 64. 3 times 37 is like this. I go on throughout. To the last one, 1 times 82. Midpoint of the last class was 82 is 82. And then I have something here I call a sigma fx. So sigma f I add, so it requires a summation of fx. So this is, and I'm not going to calculate it in this particular case. So you are going to calculate it for yourself, then you do, and then you just divide. So 27 plus 64 plus 111 plus 126 plus 141, plus 260, plus 56, plus all this. You come and get your answer, and then you write your answer here. Okay? For example, your answer can be A. You come and write your answer at A. So how do you find the mean? How do you find the mean? Okay, how do you find the mean? So I come back here and I show you how to calculate the mean. So mean is abbreviated as bar X. So let me start this. Just a moment. Just a moment. Just a moment. So my bar X is A. So bar X, okay, is equals to mean of X bar X. Let me remove caps. Let me just put a small letter. Bar X is equals to, then here is where you come now. You insert your other your fraction here, sigma fx over sigma. So I put sigma here. And also put a sigma here, down here. Sigma means summation of. So sigma fx, summation of fx over summation of f. So this is how you do your mean. So you write your mean like that. Then you have your answer here. So whatever answer you're going to get here in this column of sigma fx over sigma f, sigma f was 40. So I'm not going to calculate that for you. You can calculate that one and get the answer. So it was also marked. So it is going to be the mean mark. Some people call it the mean score. So this is how you find the mean. So the fx column, we use it to find the mean. Now for group data, we don't have the mode. For group data, we don't have the mode. We have something we call the model class. Okay. So let me come here and show you that. So for group data, you don't have the mode. You have something called the model class. You have the model class, which is the class with the highest frequency. Class with highest frequency. Okay. Something else on the confuse the two. Model frequency is the highest frequency. Model class is the class with the highest frequency. Model frequency is the highest frequency. So this is a class, this is a frequency. You should note the two. They are related but not the same. So which is the model class? Ninakuwa ni one mark. Unakuja unaangalia hapa, unaona ni gani iko na frequency the highest 3, 3, 5, 8, 5, 2, 1. Which is the highest number there? 8. So model class is 55 to 59 in your class. unaandika 55, 59, and then you get 1 mark. In the exam, you usually get mode of frequency is the highest frequency, just write that. It is the highest occurring frequency. It's called the mode of frequency. But the one which is commonly brought in the exam is the model class, the class with the highest frequency. Remember, if you write 8, instead of model class, you write the answer as 8. You are wrong. It's not a class. 8 is a score class. Then we go to the median. How do we calculate the median? To calculate the median, we require one more. And that's why you can see there's a column here I've written CF, which in full is written as cumulative frequency. I think we should have entered here cumulative frequency. Cumulative frequency, abbreviated as CF. CF, cumulative frequency. Cumulative frequency means you add the frequencies. So the first frequency here is 1. So if frequency is 1, cumulative frequency is 2. So 1 plus 2, 3. 1 plus 2, 3. 3, 6. 6 plus 3, 9. 9 plus 3, 12. 12 plus 5, 17. 17 plus 8, 25. 25 plus 5, 30. 30 plus 4, 34. Continue. 34 plus 3, 37. 37 plus 2, 39. 39 plus 1, 40. So if the cumulative frequency which aligns with the first class should be the same with sigma f. If it is not the same, it means you have made a mistake somewhere in your calculation. You have made your mistake somewhere in your calculation. So you need to be very, very keen on these small. Now, as you see, cumulative frequency does not have a sigma. Sigma for grouped data only occurs on sigma f and sigma fx. Na mahali unaona sigma iko, there is a mark. So if this was a table, you would have been given marks for the frequency distribution table. Okay. Then when you put the point of midpoint, you get around 2 or 1 mark. In the fx column, you can either get 2 or 1. Cumulative frequency is definitely 1 because you're just adding up these scores. So this is how you, this is the column called the cumulative frequency. It is important when you are estimating the median. You cannot calculate the median. You can calculate the mean and get the correct answer. But the median, to get the correct answer, it is a bit challenging. So what you have is you just estimate. So you estimate the median. So for the median, you estimate. That is what? If you look at your past papers, the ones that I give you, you can see you estimate the median. Okay. So let us estimate the median. How do we estimate the median? Let me give you the formula to estimate the median. Write this formula there, and then I'm going to explain what these numbers mean. So estimate the median, LCL. It means the lower class limits. I have not explained what the lower class limits are, so I'm just coming there. So lower class limit is equals to N over 2 minus CF. CF means cumulative frequency. All over F. F means frequency. All these are into brackets. Then you multiply by C, I, and W. In C, I, and W, these ones I'm also going to explain what they are. So let us come here and see. LCL is the lower class limit of the median class. So write it very clearly there. LCL is the lower class limit of the median class. So there are two things that you need to know here: the lower class limit and the median class. So you have to understand which is the median class. Good. N is the total frequency or sigma f. Total frequency or sigma f. That is what N means. Okay. The total frequency. Then I go to CF. CF is cumulative frequency of the class before the median class. Cumulative frequency of the class before the median class. So I said you have to understand what is the median class. F is frequency of the median class. F is frequency of the median class. C stroke I stroke W is a class width, the class interval, or the class size. Class width, class interval, or class size. I wish they would be brought in one page. Still not coming in one page, but we have them here. At least you can see most of them here. Okay. So N is total frequency. CF is LCL is the lower class limit of the median class. You can see the LCL here. So this is our formula here. Okay. So LCL is the lower class limit of the median class. Okay. LCL. N is total frequency, the same as sigma F. CF is the cumulative frequency of the class before the median class. Okay. Then F is the frequency of the median class. C stroke I stroke W is the class width, class interval, or class size. Now, let me take you to normal layouts, and then we can now start our calculations. So, how to estimate the median, you need to know the median class. So, how do you know the median class? Median class is found by this. Median class is found by N over 2 over 2 N over 2. Remember, over 2 here. I've said N is equals to total frequency, or sigma F. So you come down here and find that your sigma F is 40. And that's why in the former example you had said N is equals to sigma F is equals to 40. So to know the median class, I will come and say 40 divided by 2. 40 divided by 2. The answer is going to be 20. Now, 20. So I'll come back to my table and say in my table here, where is the 20th student falling? Because these are marks for 40 students. So 20th student alikuwa naanguka kwa marks gani? So student wa kwanza ndiye alipata between 25 and 29 marks. Only one student got those. Now, 3 students, which means wa pili na watatu, the second and the third students are the ones who got between 30 and 34. Then, from the 4th to the 6th students, they are the ones who got 35 to 39. 7 to student 9, they got this mark. Student 10, 11, and 12, they got this mark. 13 to 17, our students, they got this mark. 18 to 25, they got this mark. The 20th student falls in this class, and that's why you can see I've highlighted it in yellow. It means it is the median class. It is the median class. So the class 45 to 55 to 59 is the median class. Okay, 55 to 59 is a median class. So let us come to filling the other figures now. Okay, so when I come to this formula, I want to fill out the rest. N over 2 is 40 over 2, which is 20 here. Cumulative frequency, so CF We said CF is the cumulative frequency of the class below the median class. What happened here? CF is the cumulative frequency of the class below the median class. So I come to the median class in my table. Median class on my table. This is the median class. So cumulative frequency of the class before. Class before ni iko nyuma. So before I get to 59, 55, before I get to the median class, the class which was before is 52, 54. What is its cumulative frequency? 17. So I'm going to come here. And in my formula, when I'm doing my substitution, I am going to 10 over 2 minus CF. So it is 20 minus 17. All over F. And we have said F is the frequency of the median class. So my median class, okay, F of the median class, 8. It was 8. So I come back here. Where? I come back here and say over 8. Multiplied by CIW, which is the class width, which you know very well was 5. So the only thing that we don't have is called the lower class limit of the median class. The median class, we understand it properly. This is the median class, 55 to 59. So what 55 and 59 are, we say they are called the upper class boundary and the lower class boundary. Upper class boundary and the lower class boundary. So I want to introduce something else, which is called the class limits. So I'm going to introduce it here. Class limits. How do you know what class limits is? Now, as you can see, our classes, for example, are 25 to 29. This is the upper class, this is the lower class boundary. This is the upper class boundary. Now, from the boundaries, we can get the limits. So the numbers are 25 to 29. So we ask ourselves, when you're writing the number 25, when you're writing the number 29, you have to write this number in a certain error. So what is the error in writing this number? To get the error, you have to find the smallest measurement. Or the smallest accuracy when writing your number. Now, I want to tell you that now numbers between 1 and 99, they are written into an accuracy of 1. Accuracy, not accuracy, the accuracy. It is the smallest unit of measurement is 1. So, 1. If you want to find the error that is involved, you multiply 1 by a half. So you come here, you say 1, you multiply by a half. The topic that you did, which is called approximation and errors. So you get this one is 0.5. So numbers between 1 and 99, they are written in an error, so you can add or subtract. So you can say plus or minus. Plus or minus 0.5. Which means a number like 25, because our number which we're interested in is 25 and 29. So let me take 25 first. 25, if you want to write 25 in the biggest way, you can add plus 0.5, where your answer becomes 25.5. If you want to write 25 in the lowest, you say 25 minus 0.5, your answer becomes 24.5. So in the class 25 to 29, the smallest number you can write this class in is 24.5. And this number here becomes a lower class limit. 29. The highest way you can write 29 is to add 0.5, which is the error, and you get the answer is 29.5. Okay. The smallest way that you can write this number is 29 minus 0.5, but you get your answer is 28.5. But we're interested in the highest way that you can write 29. So this one becomes the upper class limit. So you can say for the class 25 to 29, when we're talking about the class limits, the lower class limit is 24.5. The higher class limit is, the upper class limit is 29.5. Now the next class from this is 30 to 39. So the next class here is 30 to 39. Sorry, 30 to 34. 30 to 34 because you're using a class limit of 5. So the smallest way you can write 30 is what? Which is the smallest way you can write 30? So you say 30 minus 0.5, so it is what? 29.5. The highest way you can write 34 is 34.5. So you can see that in this class, in the class 25 to 29, the lower class limit is 24.5, the upper one is 29.5. The following class, which follows it, okay, which is 30 to 34, the lower class limit is 29.5. The other one is 34.5. So as you can see, the upper class limit of one class is the lower class limit of the next class. And then this is where I'm going to bring you here. I'm just going to bring you here. So let's just enter here, enter. And then we make it smaller so that you can see. You can now see everything. So the class limit and the upper class limits are 24.5, 29.5. So the lower class limit, the upper class limit of this class becomes the lower class limit of the next class. The upper class limit of this class becomes like that, like that, like that. So this is how you find the upper class limit. So for example, for this one is 79.5 because the smallest way to write 80 to 84.5. 84.5. So this is how you write the upper and the lower class limit. So our median class is 55 to 59. Lower class limit is what? 54.5. So that's why when we came down here writing our formula, okay, of the lower class limit of the median class, remember the median class was 55 to 59. So the lower class limit is 54.5. Okay, so 20 minus 17 is 3 over 8. You multiply by 5. And this is the answer. The answer is 1.875. And then you want 54.5. But you get the answer 56.375. So this is the median mark. So to estimate the marks, it is 56.375. Remember, you can be told to write this one in 4 significant figures. Okay, how do you write significant figures? You start with the leftmost and 0. So 54, 56. Okay, so 1, 2, 3, 4. You consider the fifth. Is it significant? Yes. Can it be rounded off? Yes, it is 5. It can be rounded off. So the answer now becomes 56.38. 56.38 marks. This one is in 4 significant figures. If the examiner has said you write it so 4 significant figures. So that is how you estimate the median. Now remember, this video is going to be uploaded on YouTube, so you can go back and you can refer to YouTube. You can watch the video, you can replay the video, you can watch it as many times as you want, and then you can now be able to see each and every step how I am doing it. So this is how you calculate the median of, you estimate the median of grouped data. This is how you estimate the median of grouped data. And so we are left with one more thing in this topic. We are left with one more thing in this topic. So let me come back here and see. You can see you are still there. Any new person was joined us? No. So any person who remember I've put the attendance there, you can mark your attendance. Yes, you can mark the attendance. So okay, just we can mark this one now. Yes. Good. So we are good to go. So yes. Okay. So we now move to the last part of this topic. Where we go now. Remember, we have looked at measures of central tendency. We can now go and look at measures of dispersion. Okay, measures of dispersion. So I'll continue with my screen share. Yes, so I'm now starting to share my screen. So I'm sharing my screen, so I think everybody can see that. Okay. If you don't see my screen, problem is a problem of the net on the network. So you need to sort that one out. So measures of dispersion. Now, so we want to start by asking ourselves, what are measures of dispersion? And what do they calculate? And how different are they from the measures of central tendency? Now, the ones that we are going to look at, according to a syllabus, according to your syllabus, the measures of dispersion that we want to look at, let me just come and show you. That we are going to look at in this particular case is now obviously when you're looking at this, you look at the variance and something we call standard deviation. Okay. Standard deviation, variance and standard deviation. Okay. Now, so in statistics, we say the measures of dispersion, they calculate something called variability. So dispersion is called variability. Okay, in statistics, it's called variability, and that's why you can see you're calculating variance here. Variability. What does that mean? Variability is to scatter or to spread. So we look at the extent, okay? The extent which a distribution is stretched or squeezed. Squeezed or squeezed. Okay. So basically the ones that we look at here, I've said is variance, standard deviation, and we can look at things like interquartile range. Excuse me. Interquartile range. The interquartile range. So these are some of them that we look at. Basically, the ones that are most tested are variance and standard deviation. Okay. So if you look at, if you compare the measures of dispersion and the measures of central tendency, in central tendency, they tend to circle around a certain mark. But here we are looking at all the marks, how they are stretched and how they are squeezed. So it is able to show a certain the dispersion, how a certain distribution tends to scatter and how it spreads. So we are able to account to each and every variable, each and every score in that distribution equally, not in a better way like what we look in the measures of central tendency, the measures of central tendency. Now, so I will start by calculating one here called the mean absolute deviation. Mean absolute deviation. Now, how do you calculate the mean absolute deviation? Now, absolute, we write absolute where we put, let me show you how we write absolute here. Something is absolute, it means it cannot be zero. Let me show you how we write absolute. I want to insert something here, so be patient. Is wrong with my word. Absolute, absolute, absolute. Where are you? Just a moment. Something is wrong with my word document. Okay, so I have this. So let me look for absolute. Cannot be seen here. I cannot see the meaning of absolute here. Let me I can that is something somewhere. So absolute means it's not zero. I'll show you. I will look for that meaning to put it. So let's continue actually with what I'm doing. Okay, so let us look at the mean absolute deviation. Then from there is where we are going to look at the variance, and then we have the standard deviation. So let me just give you an example here. Mean absolute deviation. Okay, so let me just look for an example. When I put it here, we calculate it, and then we are good to go. Just a moment. Okay, calculate the mean absolute deviation. Okay. M A D. I'm going to call it like that. Okay? MAD of 3, 6, 6, 7, 8, 11, 15, 16. 3, 6, 6, 7, 8, 11, 15, and 16. So you are given such an example. So you find the mean absolute deviation. So you come here, usually come here and then you insert your table. Okay. How many are they? 2, 3, 4, 5, 6, 7, 8. I don't know whether I'm going to use all of them. Up to there, I think it's going to be enough. So here I come, I write x. Okay, it is x. So here x here represent the mass, and here I'm going to have. I'm not writing that one because I don't have the. So we have 3. So here I write 6. I'm just going to write. Okay, I write 6. I write 7. I write 8. I write 11. Then I have 15. Means I'm going to add. I'm down here. So I want to add some 2 more rows here. Insert. I want to insert rows below. So I can put my 16, and then I can have the last one where I am going to be doing my calculation. Rows below. So this is my 16 here. This is where I'm going to have my sigmas. Okay, for x. So absolute. Okay, so I need to look at that where I put my absolute. So just a moment. Where is it now? Now I'm just going to improvise. So I'm just going to put a small L. And so that's like a stroke. Yeah? And then I put here, I'm going to call this one D. Okay, I'm going to have X. Let me first of all say by X. So I insert by X. I'll explain everything in just a moment here. Absolute should be have been here, but anyway, there's no problem. So I want to insert by X here. By X means mean. Okay. sorry. So you have X minus the mean. So I'm going to say here, this column I'm going to call it, this thing is becoming slow. D, not capital D, but small d. Difference column. So I'm going to have a difference column here. And then here I'm going to have something called absolute D. So let me come and show you how we write it. It's not L. Hii ni kama kamuti imechorwa hapo. So akastroke, a D, akastick a D, and then another stick. Or actually, I think I have one here. Yes. So I can write absolute using this one. I don't have to have so much trouble with it. Absolute D. Okay, that's absolute D. Just a moment. Just excuse me, just a moment. So here I am. So that's absolute D. Okay. So the first step is you find the mean or the mean of this mean. Mean is average. So how do you find the mean? So you just say it is. I'm taking so much time inserting this fraction. So here we are going to say now here. Nafanya ile hesabu 3 plus 6 plus 6 plus 7 plus 8 plus 11 plus 15 plus 8. And then here, divided by n. N ni ngapi? So 1, 2, 3, 4, 5, 6, 7, 8. So we can say n is equals to 8. So here you divide by, so you say n is equals to 8. And then you come here, and then you have your answer. So 3 plus 6 plus 7 plus 8 plus all that. So today I'm going to use a calculator, just like I said. We need to move on quite fast. So 3 plus 6 plus 6 plus 7 plus 8 plus 11 plus 15 plus 16. The answer is 72. 72 I divided by 8. You very well know what the answer to that one is 9. So the mean is 9. Mean is what we call bar x. So in this column, this is the column of D, differences column. So that means x in here column minus mean. So for example, this first case here, I'm going to say 3 minus 9. And the answer obviously is negative 6. Okay, so here I say 6 minus 9, the answer is negative 3. 6 minus 9 again is negative 3. 7 minus 9 is negative 2. So you are saying this, x minus this. X is 3, mean is 9. Mean you can take 9 up. So I've just given you the first example, 3 minus 9, negative 6. 6 minus 9, and so on and so forth. So negative 1. So this one is going to be 11 minus 9. And then the answer is becoming positive. So the answer to that one is 2. Okay. You don't have to write that one. You just write the answer here in the exam. So 11 minus 15 minus 9 is 6. This one is 7. Okay. Yes. Now, what does absolute mean? Absolute means the number cannot be negative. So if it is negative 6, you ignore negative 6 and you write it as positive 6. This is negative 3. So D was negative 3, so you ignore the negative. So continue ignoring the negatives here. Okay? You just ignore the negatives. That's what absolute means. And that's why it's not a very good way to calculate. So positive, you just put them as positive. You cannot ignore the positive. So the positives are just going to remain as positive. And here, you are going to have a sigma now. Sigma D. So you come here and you put your sigma. You have to bear with me. I think I'm having a small cold. So why can't I see it? Excuse me. Excuse me, this thing, something is hanging here. Just a moment. Let me stop this share here. Something was hanging, so let me sort it out. Then I can go back to the share. I'm hoping now it is behaving the right way. Why is it not displaying my sigma? Not happening. Something is wrong with this Word document of mine. Why is it not displaying whatever I want? This is quite funny. So you're supposed to come and put your sigma here. I don't know why this one is not displaying whatever I want. Hey, hey. So you come, you add 6 plus 3 plus 3. 6 plus 3 is 9. Plus 3 is 12. Plus 2 is 14. 15. 15 plus 3 plus 2 is 17. 17 plus 6, this is 23. Plus 7 is 30. So here this one is 30. Allow me to close this thing and open it again, because as you can see it is not typing. So stop sharing. Just a moment. I need to close it and then I need to come back here and see what's wrong with it. The Word document is hanging, which is a terrible thing. So let me just do something to remove it. So let me try to open it again and see whether it's going to misbehave. It's not doing the right thing. Where is this? Just a minute. Now it is okay. So let me come back and share. What is wrong with the car? I thought I muted every car to ziko sana. Can you make sure that your mic is muted? Okay, let me now continue with my screen share without any interruption. See, it has deleted everything here. So this one was absolute D. Just repeat. So this one is D is equals to not capital D, small d. Saving my work so it does not get lost again. Okay, so I said this one is D, X is 3. So this was 9. You start by calculating the mean here. This one was equals to 72. 72, which we divided by 8 because 8 was the n, because the answer was 9. So mean is equal to 9. Mean is equals to 0. So you have 3. Just the first one, an example is minus 9 is equal to negative 6. The rest I just continue. Negative 3, negative 3, negative 2, negative 1. This one is 11 minus now 9. Answers become positive from this particular case. Here we have 6, and probably this one 9. Okay. So absolute means you ignore the negative. So this is positive 6, positive 3, positive 3, positive 2, positive 1. Obviously, these are positive. You cannot ignore the positive. We ignore the negative so that they can be positive. So this is 6 plus 3 plus 2 plus 1. There are 2 3s. 6, okay, 6 plus 3 plus 3 plus 2 plus 1 plus 2 plus 6 plus 9. I think our answer is different now. 6 plus 3 plus 3 plus 2. 16 minus this is wrong. Oh, this is 9. 16 minus, let me see. 16 minus 9 cannot be 9. 16 minus 9 cannot be 9. So this one is 7. So this one is 7 here. That's why the answer here is 30. This is sigma of absolute D. This is how you write absolute, like that. Here you can see me doing. Okay. Yes. So to calculate mean absolute, you require mean. So you require mean. So you have already calculated the mean. So you say 3 plus 6 plus 6 plus 7 plus 8 plus 11 plus 15 plus 16. 72 divided by 8. 8 is what? These were 8 scores. 1, 2, 3, 4, 5, 6, 7, 8. The answer is 9. So you come, you say difference between the x and the mean. So it is 3 minus 9, negative 6. 6 minus 9, negative 3, and so on. So you come and fill the whole of this column here. Okay. And the reason why I was doing that one, I was doing that one as an example, so you don't have to come and do that. So it's just an example to show you how we are calculating that. Okay. Then we have absolute. Absolute means you ignore the negative. So there's negative 6. You ignore the negative, you just put positives here. And then you have sigma absolute D, which is that. So to find your MAD here, I can see in the chat somebody was asking what is MAD. And she was well answered. So that I think that is very good. Mean absolute deviation is equals to, so we come here and write this. Okay, imekuja hapa chini is sigma FD. So you come and insert your sigma here. So sigma FD, sigma absolute D, sigma absolute D here over N. I don't want capital N, I want small n. And figure this. So yes, just want to do some network here. Yes, my word was hanging, but you can see now it is okay. That T over N is 8. And so the answer is divided by 8. 3.75. Remember these were marks, 3.75. So there you calculate the mean absolute deviation. So you start by calculating the average or the mean. So you say 3 plus 6 plus 6 plus 7 plus 8 plus 11 plus 15 plus 16. That is 72. You divide by n. You have to find n. N is 1, 2, 3, 4, 5, 6, 7, 8. There are 8 frequencies that are there. So you divide by 8. You get the answer is 9. The next step is now you come and see differences column. Difference. D is for difference. You can use a difference, and you can use M. You can use T, whatever you want. But T, the difference is 1 is equals to x minus mean. But x means mean of x, which is 9. So x in this case is 3 minus 9, negative 6. 6 minus 9, negative 3. 6 minus 9, negative 3. All the way 16 minus 9, 7. Then you come here, you say absolute D. You ignore. Yeah? You ignore, which is not a good thing, by the way. Mean absolute deviation, absolute deviation or mean deviation it's not a good thing to ignore, but basically people still continue ignoring. So you add these ones, so you have a sigma absolute D, which is that. So some people are going to call it mean deviation or mean absolute deviation. If they say they skip the name absolute, remember absolute is important because it means we ignore the negative. We mean absolute deviation. Okay. So what does this mean now? So as you can see, the answer is 3.75. So what this means, it tells us how far, on average, all values are from the middle, or we can say from the mean. So inatuambia, so 3.75 it means if the mean was 9, all these figures, they are 3.75 from the mean. So it is on average. So on average, all these figures here going from 3 to 16, and the mean is 9. The difference between 3, 6, 6, this one, the mean is 9. So these figures, they range, or their average value from how far they are from the mean, which is 9, is 3.75. Okay? So that is what this means. So all the values are on average of 3.7 away from the middle or from the mean. This one is called the mean absolute deviation. And the formula is sigma absolute D over N. Okay? Over N. So I think you have written this one properly. So one is for the mean absolute deviation. So it is a measure of dispersion. It tells us how far averages or values are from the mean. Now, to correct the problem of ignoring, is where now we have the variance. This is where we come up with the variance. And the formula for doing for using variance here, okay, the formula for calculating the variance here is, instead of ignoring, you see here we have ignored in this column, here we've ignored. So ignore this column now. Ignore the whole of this column. So let me put some color on it. And I'm hoping that you're going to ignore it. Some moments. I want to pour some color on it. So you just ignore it. Okay, I'm just pouring some color on it. Just ignore it. So you would, for you to calculate variance, instead of having this, instead of ignoring the negative, you would have come here and have the column of d squared. This is small d, not capital D. D squared. So you come and you square your d. So you see that is a positive way of removing negative. Instead of ignoring, you just square. So you come here, you get 6 squared, negative 6 times negative 6 is 36. Negative 3 times negative 3 is 9. Remember, every number squared has to be positive. This one is also 9. This one is 4. Negative 2 times negative 2 is 4. Negative 1 times negative 1 is 1. 2 times 2 is 4. 6 times 6 is 36. 36. 7 squared is 49. And then here, I come and have the sigma for this. So I come and have the sigma for this. So it's going to be called sigma d squared. Okay. Sigma d squared. And we are finishing this lesson. So just a moment. Equals. So you come and add all this. Okay. So let me add it. 36 plus 9 plus 9 plus 4 plus 1 plus 4 36 plus 49. The answer here is 148. Okay. So to find the variance is also written as, let me show you, variance is also written as s squared. Okay, s squared means I'm just okay, no? So variance is equals to, then we come here, we put our formula, we start our formula very fast. What I want. So here I come and say sigma d squared. Yeah, haitanipea nini? Okay, it's not going to give me. Okay, I would have come here and then I write like this, so that they can give me the correct thing. Sigma d squared over n. And the answer to that is 148 over 30. And the answer now becomes 148 divided 30, 4.99, 4.933. So you can see there's a difference in the answer. Okay. So I'm hoping here you have done correctly. 36, 9, 9, 4, 1, 4, 36, 49. Correct? So 148 divide. So variance or S squared is sigma d squared over n, which is 148 over 30. So the variance now is what? Variance, now you can see the answer to the variance is 4.9333 compared to 3.75. You can see there is a difference in the answer. So variance, we can say it measures how. Let me come here to tell you what is the purpose of variance. So variance, this one measures how low or how far. Let me just use the word far. How far a set of numbers are spread from their average value. Remember, average is mean. Remember, we said the measures of dispersion, they look at what? How it is stretched, or how they vary, how they stretch, or how they are squeezed. So however a set of numbers spread from the average value or from the mean. But for the measures of central tendency, how they just circle or how they move around the mean. But here we look at how they spread. So you can see they are spreading at 4.933. Now let us look at standard deviation. Standard deviation is very simple. Standard deviation is abbreviated as S. I think you now understand why. Let me put this one as capital S. So it's just S. So that means it is square root of standard deviation. This is square root. This is the square root of S squared. What put is here. The answer here is square root of 4.933. You take a calculator, then you find the square root of the answer. The square root of 4.933 is 2.221. This is the standard deviation. This is the standard deviation. This is the standard deviation. Standard deviation. Standard. So this is how you find standard deviation. So if someone tells you to find standard deviation of ungrouped data, okay, you just find the variance. You use this formula to find the variance. So you ignore this. So this column ingekuwa. So you just come here. You do everything the way we did. Find the mean first of all. You find the mean is 9. Okay. Then you come. You find the difference is column, and then you don't use it. This column is only used for mean absolute deviation. So to find the variance or the standard deviation, just instead of ignoring the negative, you square the negative. So you come and find this. So after you come and find the variance, you can now find the standard. You can find the square root of the variance. So square root of variance is equals to standard deviation. That's why you can see variance is S squared and standard deviation is S. So you find the square root and then you get the answer. So it expresses how much members of the group differ from the mean. Okay? So standard deviation kazi yake ni gani? Standard S the standard deviation. This one is a quantity expressing how members of the group, members in hizo namba ziko hapo, okay, of the group differ is from the word difference, differ from the mean. Okay? Mean means it's like that list measures how set our number spread from the mean. So we take it in relation to the mean. So you see now you use mean to look at how far measures or as members of that group or a set of scores, okay, or a set of numbers, they spread from the average. How far, how they stretch and how they squeeze from the mean. That is what standard deviation is. And this, now with those very, very many remarks, we will come to the end of that topic. I know I've just done one example, but the reason I'm doing this is I know we are going to have a video that I'm going to save, and then you're going to go to YouTube, and then you can view it as many times as you can. And then you can read your questions so that by the next lesson, the questions can be ready for us. If you have a small question, you can even ask it right now, and then I'll be happy to answer it. But if it's a big question, I will answer you later because I have another class that I need to attend. So I can now answer that question some other time or just beginning of the next lesson. So you have the questions ready and then you have them. Now assignments, I remember I need to send the assignment of all the topics you've covered up to there. And I'm also going to give cut 1. Remember we are now entering the week where we're supposed to be doing our cuts. So you need to understand that is going to be done. So let me stop my recording. Nice.